The Sun, 27 million degrees Fahrenheit. Space, -455 degrees Fahrenheit. 2 trillion galaxies, billions of stars, and space is still almost completely frozen. How is that possible? The answer requires rethinking something fundamental, something most people never question: what temperature actually is, and why space barely has any. Temperature is not a property of empty space. It is a property of matter. It measures how fast particles are moving and vibrating inside an object. A hot object has particles moving furiously. A cold object has particles nearly still. Absolute zero is the point where particle motion drops to its theoretical minimum. And here is the key: if there are no particles, there is no temperature. You cannot measure the temperature of nothing. Deep space contains roughly 1 atom per cubic meter. Earth's air has 25 quintillion molecules in that same space, almost nothing in space to hold any heat at all. The Sun releases an almost incomprehensible amount of energy every second, and almost none of it heats the space it travels through. Because the vacuum has almost nothing in it to be heated, the energy passes through and keeps going, forever. Heat travels in exactly 3 ways, and in space, 2 of them are completely impossible. Conduction, heat flowing directly between objects that are touching. In space, objects are not touching, nothing to conduct through, eliminated. Convection, heat carried by a moving fluid, air, water, gas. Space is a vacuum, no fluid, no medium, completely eliminated. That leaves radiation, electromagnetic waves that need no medium at all. This is how the Sun's energy crosses 93 million miles of empty space to reach Earth. But radiation does not heat the vacuum it travels through. It only heats the objects it actually strikes. The waves pass through space, and space feels nothing. Only when that radiation hits something with mass, a planet, a moon, a spacecraft, a grain of dust, does the energy transfer and create warmth. Space is not cold because the Sun is far away. Space is cold because space has almost nothing in it to be heated by the radiation passing through it. But if space is freezing, why do spacecraft need cooling systems? Why do space suits manage heat as much as cold? Because space presents 2 extreme conditions at once. The sunlit side of an object in space can reach +250 degrees Fahrenheit. The shaded side, a few feet away, drops to -290 degrees Fahrenheit. The ISS swings between +250 degrees Fahrenheit and -250 degrees Fahrenheit every 90 minutes as it orbits in and out of sunlight. Engineers design every component for both extremes simultaneously. Earth avoids this because our atmosphere absorbs heat, distributes it, and smooths out the extremes. Remove the atmosphere, and Earth would behave exactly like the Moon. And the Moon proves every single thing we have just explained. On the lunar surface, in direct sunlight at the equator, the temperature reaches +250 degrees Fahrenheit, hot enough to boil water. Walk into the shadow of a crater just a few feet away, and it drops to -290 degrees Fahrenheit. Those 2 temperatures exist simultaneously, separated by nothing but a shadow. No atmosphere means nothing distributes the heat. Sunlight hits, that spot gets hot. Shadow falls, the heat bleeds immediately back into the vacuum. Mercury, the closest planet to the Sun, gets colder than Mars at night, not despite being close to the Sun, because it has almost no atmosphere to hold any heat. Venus, farther from the Sun than Mercury, is hotter than Mercury on average. Its thick atmosphere traps heat so completely the surface never cools down. Distance is not the answer. Atmosphere is. And there is one final layer to this story that makes everything stranger. The entire universe is filled with a faint glow of radiation left over from the Big Bang. It fills every centimeter of space in every direction equally. Stretched and cooled by 13.8 billion years of cosmic expansion, that radiation now sits at -455 degrees Fahrenheit, just 4.7 degrees above absolute zero, the baseline temperature of the universe. And it is getting colder. As the universe expands, that background radiation continues to cool. The universe today is colder than it has ever been at any previous point in its history. NASA's Parker Solar Probe flew within 6.5 million miles of the Sun. Its heat shield faces 2,500 degrees Fahrenheit, hot enough to melt steel. The instruments on the other side of that shield sit at negative 238 degrees Fahrenheit. Move a few feet into the shield's shadow, and you go from an inferno to a deep freeze. Not a flaw in the design, physics working exactly as expected. The Sun is not warming space, it is warming the objects radiation strikes. The vacuum between them stays frozen because there is almost nothing there to absorb the energy. Earth is something extraordinary, the right distance from a star, wrapped in the right atmosphere, allowing heat to be absorbed, distributed, and held. Without that, we would be the Moon. The universe is not evenly warm. It is a collection of isolated hotspots surrounded by an almost infinite cold. The warmth we feel every day is not the default condition of the cosmos. It is a rare, precise, protected exception, and it required everything to go exactly right for billions of years to produce it. The right question is not why space is cold when the sun is so hot. The right question is, in a universe that is almost everywhere and almost always unimaginably cold, how did warmth like ours ever exist at all? Subscribe to Simple Things, Hidden Truths. We find the answers hiding inside the questions you stopped asking. Share this with someone who has ever looked up at the stars and wondered why space feels cold. New hidden truth every single day. Hit subscribe.